See this problem. A solenoid 60 centimeters long and of radius 4 centimeters has 3 layers of windings of 300 turns each. A 2 centimeter long wire of mass 2.5 grams lies inside the solenoid near its center, normal to its axis. Both the wire and the axis of the solenoid are in the horizontal plane. The wire is connected through two leads parallel to the axis of the solenoid to an external battery which supplies a current of 6 amperes in the wire. What value of current with appropriate sense of circulation in the windings of the solenoid can support the weight of the wire? G is equal to 9.8 meter per second square. Our motive is, so there is a solenoid which has n turns and some current is flowing in the solenoid, capital I, and the length of the solenoid is capital L. So there is a copper wire which kept normal to the axis of the solenoid and having some current I in it, and the length of the conductor is L. So it has some mass, so it will be pulled due to the gravitational field with a force mg. This gravitational force is balanced by the electromagnetic force due to this solenoid. We need to find out the current which is flowing in the solenoid due to that the field which is opposing the falling of this copper wire. So the current flowing in the solenoid we need to find out, that is our motive. Now come to the investigation part. What are the quantities that I have given? The solenoid has length 60 centimeters, so capital L is equal to 60 into 10 to the power of minus 2 meter, and it has radius R is equal to 4 centimeters, let it be, and it has 3 layers of windings, so total number of turns N is equal to 3 layers into number of turns per each layer, that is 300, that is equal to 900 turns. And the length of the copper wire which is kept under that solenoid L is equal to 2 centimeters, that is equal to 2 into 10 to the power of minus 2 meter, and the mass of the copper wire M is equal to 2.5 grams, that is equal to 2.5 into 10 to the power of minus 3 kg. And the current which is flowing in the copper wire I is equal to 6 amperes, and G is equal to 9.8 meter per second square. We need to find out the field of solenoid at the center, and using that we need to find out the current flowing in the solenoid. Now come to the resolving part. Here the magnetic field due to the solenoid is balancing the gravitational pull on the copper wire. So I can write like mg is equal to magnetic force, which is equal to B I L, where B is the magnetic field due to solenoid and I is the current in the copper wire and L is the length of the copper wire. So with this I can write B is equal to mg by IL. Now come to the magnetic field of a solenoid. The magnetic field at the center of the solenoid B is equal to mu naught into Ni by L. Here N is the number of turns in the solenoid and L is the length of the solenoid and I is the current flowing in the solenoid. Mu naught is the permeability of free space. So if substitute the value mg by IL is equal to mu naught into Ni by L, we need to find out I. So figure out that expression. I is equal to mg into L by IL into mu naught into N. So now substitute the values. I is equal to M is 2.5 into 10 to the power of minus 3, G is 9.8 into L is 60 into 10 to the power of minus 2 divided by I, small I, like current in the copper wire, 6 amperes into length of the copper wire, 2 into 10 to the power of minus 2 into mu naught, 4 pi into 10 to the power of minus 7, and the number of terms 900. So 10 to the power of minus 2, 10 to the power of minus 2 cancel. 6 ones are 6 tens are 1 0 and here 1 0. 2 ones are 2 4.9s are, that is equal to 2.5 into 4.9 divided by 4 into 3.14 into 9 into here 10 to the power of minus 3 on the numerator and here 10 to the power of minus 7 in denominator. So it will become 10 to the power of 4 and one more 0 here in the denominator, so you will get 10 to the power of 3. So by simplifying this you will get 108 amperes.